Hi guys, this is topic 4.1 for AP Chemistry, Introduction for Reactions. The objective is to be able to identify evidence of chemical and physical changes in matter. So what is matter? We've talked about before. Something that occupies space and contains mass. It can be organized in many ways and undergo physical chemical changes. If it's a homogeneous mixture, you can't tell the parts that make it up. If it is a heterogeneous mixture, you can tell what makes it up. Pure substance is a substance with only one thing that makes it up, so one constant composition. If it's a compound, it's a substance with a constant composition that can be broken down into elements by chemical processes, and an element is a substance that cannot be decomposed into simpler substances. Do not select an area to comment on. Physical change. Physical property of a substance changes without changing the composition. There are several types. One obvious example is our phase changes. So when you go from solid to liquid to gas, all you're doing is changing the amount of distance between each particle and how they interact with each other, but they're still the same particles, so it's not considered a chemical change, but a physical one. So increasing temperature causes the particles to move more apart and more rapidly, increase molecular motions, less likely to interact with each other. If you decrease the temperature, decrease motions, more chance for interactions. Other systems or other examples, of physical changes include separation of mixtures. So distillation we've talked about, filtration, in chromatography we talked about. Another type of physical change is deformation of the substance. Cutting, denting, tearing, stretching, those are considered physical changes. Making solutions is another example of physical change because all you're doing is increasing the distance between each particle, each molecule. Like if I put Kool-Aid's an easy one. If I put Kool-Aid into water to make it drinkable Kool-Aid, I'm not breaking down the bonds between within each sucrose molecule or whatever. I'm just increasing the distance. Physical properties, shape, texture, flexibility, density, mass. Physical changes are usually reversible. So you see on the left side, there's the 6 different types of physical changes. Increase of enthalpy in a system. So solid, liquid, and solid. So ice, water, steam. Again, how do they behave when they are in solid, liquid, gas form? You've seen that already. Chemical change is a property of a substance, how it changes, breaking of bonds, formation of new bonds. Evidence of chemical reactions include forming a precipitate. Solids that don't dissolve back into the solution, that's a precipitate. It's an insoluble solid, meaning it doesn't mix back. Color change, light, change in temperature, sounds, evolution or production of a gas. Gross. Formation of a new substance with new properties, and they're often very difficult to reverse. So remember the few types of reactions that we've seen in chemistry. Composition or synthesis is a combination. A plus B produces AB. Decomposition, breaking down, AB produces A and B. Single ionic replacement, meaning one ion kicks off another and takes its place. Double ionic replacement, they switch places completely. You have two partners that swap with each other. Acid-base neutralizations and precipitation reactions are part of this. We'll get into more of this when we talk about oxidation numbers and everything. Combustion of a hydrocarbon or a metal now. So hydrocarbon with or without oxygen plus O2 produces CO2 plus H2O. You have your metal plus O2 combining to form a new substance. All of these can be considered redox reactions or oxidation reduction reactions, and you have to know what's going on there. We'll cover that later. Using the image below, describe the types of matter and the states of matter present. So we have these images here. So whatever type of matter it is, what's the state of matter? So for example, the first one, it's considered an element because all of those are the same and identical. In each molecule, there's only one type of element present. So it's an element. So the state of matter, based on how it's drawn, it's a gas. If you look at the next one, we see that there are elements, meaning the two atoms in the same thing are the same, but also there's one where it's different. So it's a mixture of an element and a compound, and based on their spacing, these are gases. The next one, we have, looks like a mixture again. It's an element and compound, and based on their spacing, they're gases. In the fourth box, you have each particle is identical to one another, but within one particle, you have two different elements present. So it's a compound, based on the spacing, it's a gas. Here we have all the same atoms, so it's an element. Based on this, I can possibly give one or two answers, but it's a solid. If it's a liquid, it would be, maybe there would be one on top of another. That'd be it. So this here you have mixture of elements, and these are gases. For each of the following examples, decide if a chemical or physical change is taking place. Over time, solutions of iodine gradually lose color as the iodine evaporates. So it tells you that the iodine is evaporating. So this is a physical change. So this is physical. Physical change, so it's physical. Duh. A phase change. When a drop of acid landed on your, this never happened to me ever before. A small hole appears. This is chemical. When a solution of the lead 2 nitrate solution of sodium chloride are mixed in a cloudy white precipitate forms, chemical. At Halloween, many people use dry ice, so solid carbon dioxide becomes a gas. It sublimes or sublimates. Sublimation occurs. This is a physical change. All right, gentlemen, that's it for now. Let me know if any questions. Hit that like and subscribe. Okay, thanks. Bye.